Hello everyone, welcome to Working with Java Data Types. Topic: use primitive and wrapper classes including operators, parentheses, type promotion, and casting. Please watch my video till the end. If you like my video, give thumbs up and click the bell icon to subscribe to my channel for the latest updates. Primitive types. There are 8 built-in data types referred as primitive types: Boolean, byte, short, int, long, float, double, jar. Boolean is 1 bit, byte 8, short 16, integer 32, long 64, float 32, double 64, jar 16. There are 4 value type: Boolean, integral, which is non-decimal, floating point, decimal, Unicode, character. Each integral value is twice the size of smaller one. You can see the short is 16, integer 32, long 64. And same thing for the floating, is twice the size of the shorter one, 64, which is the twice of 32. The minimum value of byte is -128, maximum 127. How? 1 byte is equals to 8 bits, which means 2 raised to the power of 8 equals to 256. 2 raised to the power 8 means multiply 8 2's into each other and product is 256. Divided by 2, it gives 128. We start from -128, pass 0, and it goes all the way 127. Why we have not ended up 128 on the positive side? The reason is we have included 0 in our count. Same thing we have done with the short. All numeric values are signed negative and positive. Character is unsigned, is strictly positive. That's why character can go further beyond 32,000. Each Unicode value has corresponding integral value. Boolean, you can store either true or false. Byte, you can store any number between -128 127. Remember that the value we store in byte variable, the right hand side is by default integer. It auto box into byte. The same thing over here, it is also integer, and all non-decimal values by default are integer and all decimal values by default are double. All these 1 2 3's here are integer, but the first two auto box into corresponding data type. Long, you do not need to write long as the value is shorter than the highest value of integer. If the value becomes greater than the highest value or maximum value of integer, you have to put L. For the float, as you know, by default any decimal value is double. It doesn't auto box. When we assign to the float, you have to mention F. For the character, you can either write character or integer value between 0 to 65,535, which is the number of the limit of 16 bits. So we have not divided each side as we have done on the short. The reason why, because characters are strictly positive. The string is an object, not primitive. Remember that. The same thing I have explained here. Types variable. There are 2 types variable: primitive type variable, reference type variable. Primitive type variable is a piece of memory that stores data. It consists of type and name. So you can see that this is int is a type and number animal is a name. And the process type with the name is called as declaration, and when we assign the value we call it initialization, and the value we also call as literal. So there are a lot of parts of the memory. The main 2 parts are stack and the heap. Stack have method frames, and in each method frame we have local variables, and variables are stored in the stack if we mention them in a static method like main. Primitive types are in lower cases. For example, int, integer, float, double. Let's see. I have made one project in IntelliJ data types, and let's make one class primitive, and this class has a method primitive. It returns a long value. Let's write our first keyword boolean. We can assign either true or false. Okay. Next is byte. So if I write 1 or 1 2 3, so remember that this literal 1 is actually integer, which is 32-bit, and as long as its value is 128 to 127, it auto boxes and store into byte variable. If I put any value more than 127, like 128, it will give me a compiler error. Okay. Same thing with the short. This literal is a 32-bit integer. I can store 32,768 to 32,767. If I try to store anything beyond 32,767, which is 68, it will give me an error. Okay. Integer I equals to 1, and by default I is integer, storing integer. The values between the limit, we call it underflow, and if the value is greater than the storage box, we call it overflow. So overflow, you have seen, is not acceptable. I will tell you later on in our video that something called as casting, and we could do that, but as of now you can do that. Okay. Long, so if I say LO equals to 1, so 1 is integer and long is 64-bit integral value, so you definitely can store it. So the limit of integer is 2147483,647. Okay, so this is the maximum value of integer. If I put 8 over here, you cannot store this one. So what you need to do, you need to put L, because long has a capacity, but by default non-decimal value is integer, and if you write anything after the value, it will give an error. So to avoid it, you need to put L to store the value into the storage box. Okay. Next is float. If I write f equals to 3.14, it will give me an error. The reason why, the decimal values are double. To avoid that problem, we have to mention f. No matter what happens, it does not auto box as the compiler does for the byte and short. Okay. And double, if I say d equals to 3.14, so double is going into the double, that's perfectly fine. So this is by default double value, any decimal value. And I say character C equals to A. So remember that we can put the character, we can also store integer, and this integer value is from 0 to 65,535. Okay. So this integer automatically convert into the short before storing into the character, because character is 16-bit Unicode, same as short. Let's see that. Can we store character into a byte? Yes, we can do it. Same thing with the short. Integer, long, float, double, so we can store the characters into the all integral data types. Remember that there's a question in the exam about this. Let's see that. Can we store integer into the long? Yes, we can do it. What about integer in float? Yes, we can do it. What about integer in double? Yes. So these are all higher data types, so we can store 32-bit integer into long, float, and double. So what about, can we store a long into a float? Yes, we can do it. One thing, remember that if I write a maximum limit of integer plus 1, so it gives a compiler error, and we change into the long, how it would store in the float. So it would store like 2.147483665, and then e means raised to the power 9. So it will store in scientific notation, and same thing with the double. So in the double we can store a long, what about, can we store a float in a double? Yes, it is allowed. All smaller data types can go into a higher data types. So why would we store a character into a byte? If the Unicode of a character is between -128 to 127, then we can store into the lower bit data type. So A is 97, so we could store very easily. Later I will tell you how could we store a higher data types into a smaller data type, which is called as overflow. That can only be done through casting. One thing I would like to mention, it is also very important that integer literal and character Unicode can auto box in byte and short. but if we have a byte and short and integer variable, then it won't behave the same. For instance, we can assign B, which is a shorter data type, into higher data type short, but convert is not possible. So this time the compiler cannot figure out what is the value of S, so it just checked that a short can hold higher values than the byte. That's why it gives a compiler error. Same thing if we do over here. So integer can hold byte and integer can hold short, but opposite is not permissible. Make sure if this comes in the exam, so do not miss out. So far all the examples we have seen over here are the examples of underflow. Here the underboxing applies to a literal which can fit into the variable. So this all is underflow. So I will come back to this example during the casting. So this is a very good summary class to understand data types. I also do some part of the code in J shell. So I put cmd command prompt. I'm using the white background with the black font color. I would advise please go to the terminal, copy the path and change directory to our project folder. So any code I'll write in the J shell I can later save into our project folder, and then we put it on GitHub. So all codes are available. So this is a J shell. If I write short bird equals to D, so you can see that the D is a character, so it can easily store into the short. And if I say jar mammal equals to 83, so what would happen? The compiler will put short here before storing into the character, and then convert number 83 to S. So 97 is A, small a. Now short reptile equals to 65,535. As you know that the limit of the short is 32,767. This is way bigger, so it cannot store and say possibly lost conversion from into short. By default this value is integer. And same thing if I say character fish. So if I would like to store any negative, so as you know that we cannot do with the characters, they are strictly positive from 0 to 65,535. Let's do with the long. If I say max 3 1 2 3 4 5 6 7 8 9, so will it store? Definitely not, because the integer number is too large. So to mention this is not integer long, we need to put L. Okay, Next, number system. There are 4 number system. By default, the number system is decimal. So any number you write like 17, it display as per decimal number system. Octal. The digits are 0 to 7, 8 digits, base 8, prefix 0. So if you write a 0 before any number, 017, it won't print 17. It will print 15. Reason why it is according to the base 8 system. So base 8 means each number 0, 1 and 7 you multiply by 8 and then add them. The first 7 will have 8 power 0, second one 8 power 1, and third one will have 8 power 2. So when you add them, it will give 15. Okay, so how it is 8 raised to the power 2 multiplied by 0 and then plus 8 raised to the power 1 multiplied by 1, then plus 8 raised to the power 0 multiplied by 7. So as you know that 8 to the power 0, any number power 0 becomes 1. 8 to the power 1 becomes 8. 8 to the power 2, 8 multiplied by 8 is 64. So 864 becomes 0, 8 multiplied by 1, 8, and 1 multiplied by 7, 7. So multiply precedence is higher than the positive and it will give the 15. Okay, we will go over the precedence. These type of the questions come in the exam as well about the operator precedence. We will go later. Next is hexadecimal. Hexadecimal. Hexa means 6, decimal means 10. So there are 16 digits and letters. So 10 digits and 6 letters, either be capital or lowercase. Base is 16. Prefix you have to write 0x. And hexadecimal and number systems are not case sensitive. Remember that. So if I write 0xFF, it will give 255. It won't gonna ask you to convert the number system on exam, but you have to recognize valid literal values that can be assigned to a number. Okay, so you can also write 0xFF all capital, the same thing, or 0 combination is x small x capital F and small f. Okay, so everything is same. All right, next binary. Binary means 2. There are 2 digits, 0 and 1. Base is 2, and prefix you use 0 followed by small b or capital B. So if I say 0B10, so what it gives 2. What it means actually, it actually 2 raised to the power 1 multiplied by 1 plus 2 raised to the power 0 multiplied by 0. So any number power 0 becomes 1, and 2 power 1 becomes 2. So 2 multiplied by 1, 2, 1 multiplied by 0, 0, and 2 plus 0 is 2. Okay, what would if I do 0B01? So same thing, if you do up there, it will give you 1. Okay, so if you do 2 multiplied by 0 plus 1 multiplied by 1. So how you get the 2 and the 1 before multiplication, I already have shown you. So it gives a 1. Okay, so this is a binary system. Literal and underscore characters. You can add underscore except at the beginning of the literal, at the end of a literal, right before the decimal point, or right after the decimal point. If I have a integer, I say million. So how many zeros do we have in million? We know it is 6. 1, 2, 3, 4, 5, 6. It is not quite readable. So for readability, I cannot put commas. However, I can put underscores. So now it gives a readability. So this is million. Okay. As I said, we cannot put underscore beginning of the number. We cannot put at the end of number. We cannot put before the decimal point, and we cannot put after the decimal point. But we can put anywhere else. Like I can do like this, I can do like this, I can do like this. It compiles, but it looks ugly. I can also do like this, all underscore and 2. It compiles, but it looks ugly. Okay. We talk about a lot identifier. What is the meaning of identifier? Identifier is the name of variable. So far you have seen. And like INTI. Method, like you say main method is an identifier. Class, as I define the primitive class, is an identifier. Interface, we will see in the future videos about object-oriented what are the interfaces. So interface name also is an identifier. Package, which we have defined in our previous video, and here we also have a package com.company in the main class is identifier. So identifier means a name of anything, variable, method, class, interface, package. There are some rules that it must begin with a letter, a $sign, or underscore symbol. It can include number but not start with them. So it means that the number can be in between. Okay. A single underscore is not allowed as an identifier. Okay. Next, you cannot use the same name as Java reserved words. So what are the reserved words? Reserved words are all your data types and some literal values and SS modifiers and anything which I highlight in this and previous videos and future videos in the blue. Those are the reserved words. So you cannot use them. Method and variable names, class and interface name, we use camel casing. Camel casing could be like a separating two words by the first character. So for the method and variable, the first letter being the lowercase, followed by the second letter case uppercase. Class and interface, first and second letter of the word are capital. Also, do not start any class with $, as a compiler uses this symbol for some files. And constant, static final, and enum values are often written in snake case. Snake case means all capital letters in word and joined together by underscore. So let's see some examples. If I say long OK identifier, so you see that the readability is very bad, is OK identifier, but what would if I make O capital? Oh, what would if I make I capital so it can make the good readability? Somebody can read O kid in the fire like this. So if I write down float $, OK to identifier, put here 3, put here 3. So it is legal but no good readability. Same thing, boolean underscore also OK identifier, the same issue, not good readability. If I say still OK but not so nice. If I say char, so it's valid but not good readability. If I say char as still OK but not so nice, it's OK but not good readability. So what would if I write int 3D point class? So this identifier start with letter, this identifier start with number, it's not allowed. It gave a compiler error. Next, if we use anything other than letter, digit, dollar or underscore, so it will give an error. Okay, it's not allowed. If I put string, same thing, coffee, it gave an error. Next, if I use any reserve word, it will give me an error. If I use only underscore, it will give me an error. Okay, let's come back to our project, and I would like to make a class multiple variables. In this one, I am going to write a method sand fence. If I write string s1 s2, So I can declare two identifier with one type. What about initialization? So I can also initialize two identifiers with the one type. Okay. What about if I write void paint fence and I write int I1 I2 I3 equals to 0. So what would happen here? I1, I2 and I3, only I3 gets initialized and I2 and I3. What happened here? I3 get initialized, I1 and I2 are declared. So we can do declaration and declaration with the initialization at the same time, mixed. What would if I put two types in the same line, num and string value? Can I do that? No, it's not allowed, right? So let's make legal declaration. So look at that, I am writing the method name, which is also called as identifier, with a camel case. The first letter is small and the second one is capital. Boolean b1 b2, one type, two identifiers, yes. String s1 equals to 1, and s2. So the first string is declared and initialized, the second one is only declared. So mixing is all allowed as long as there's no any other type. If I put double d1 double d2, is it allowed? No, because I have mentioned here type twice, so it is illegal. What about instead of a comma, it is if I put a semicolon? Make sure in exam you see that is it a comma or a semicolon, then it is allowed. Then it deal as the variables are declared in different line. The one statement end at the semicolon in Java. What I do, int I1 int I2, same as I explained, yes, it is allowed. What I do, int I3, instead of a comma I use a semicolon, and then I4. So what it means, it is not allowed. So what it actually looks like, these three are in one line and this one has no type. Control Z and commit this one. One more thing I would like to mention here, you cannot use a variable that is not initialized. So if I would like to use I1, it will give a compiler error. There is a question in the exam where they have used a reference of a string object and call a method. So if the object is not initialized, it will give compiler error. A constant static final and enum values are often written in snake case. If I import here java.awt.color class, which has a lot of constants, so all these colors in the capital are the constant, and this is a snake casing dark blue, so they put the underscore to separate the word. So this is just to show you. Okay, so I say BL, so say there are two B, blue or black, I say blue. So all right, so this one has a particular value R, G, and B, this one. Okay, so this is a way to write the constant in the snake casing in the Java. Let's save all of our commands in the project. So for that we will write save minus all primitive minus all dot jshell file jsh. So it will save all the commands in our project. If I go to the project, open up, so it has saved all. By default import the first command we wrote, and some had errors also, we can see them until the last one. Later on you can open it and run it. The second is a reference type variable. Primitive type is storing the data on the stack. Reference type is a piece of a memory that stores the memory address where the object is located. Object is in the heap and has an address. That address stores in the stack inside the reference type variable. If I write like a date today equals to new, so what would happen? Date, the today, will stay if it is in the main method, then in the method which is in the stack, and it has a memory address of an object that is created in heap. It has day, month, and year. So it's right here, and this is the data object. Okay, all right, let's go back. If I say string greeting equals to new string how are you, whenever there's a new word, what it does, it creates a new object in the memory. So you can see that it has created a new object, how are you, string, and the address of this object is stored in the reference variable. So reference variable are a little bit different than the primitive type variable. Okay, so the primitive type variable have only declaration and initialization. This also have instantiation. Why we need instantiation? Because we need the place in the memory. That's why we need there is instantiation. What are the values, the objects, the values of the reference type? Reference variables, type variables are stored in stack, as I said, and the object in the heap. Think that this reference type variable is in the main method. So it's about the string class, it is a special class. So whenever we use new keyword, it creates the memory and also creates string literal in a pool, which is we call it constant pool. So about the string is the next video, topic number 2, and I have explained with the diagram. So whenever we use the new keyword, then there's an object creates, and as well as the values goes in the pool. The reason is so for fast processing of the strings, and you can get the value if it is in the pool. So do not create over and over, and that is in the next video. So the reference type variable can be assigned to another object or the same or compatible type. If I create a new date and assign to today, I could definitely do that. It can assign to a new object using a new keyword, as I have explained. The beauty of this one is you can assign null. Null means nothing. So when you assign the null, then what happened? the memory address, take out the memory address from the reference type variable, and alarm the garbage collector that reference type variable is available for a garbage collection. You can think the garbage collection is like a garbage truck. You can put the garbage outside your home, and garbage truck is a schedule and comes on its own time and pick up the garbage and go. So you have no control over it. It's the same thing over here, like that. So this is if you put the null to some object as a value, so the reference, the object in the heap, actually it is allowed to pick by the garbage collector, and the reference of the memory address is it vanishes. And the beauty of the object, it has a fields and a methods, and you can call methods by the reference type variable. You cannot do with the primitive type. All right, they have only the values. And the reference type variables are of the classes, and classes begin with uppercase letter. There's also a camel casing for some classes name, and but they begin with the upper letter case, and the primitive type by the lower case letter. Okay, all right. So if you would like to see how it would be, so if I say that date, so date is in java.util. Okay, if I say today equals to new date, and if I say string greetings equals to new string how are you. Okay, so this is a way to declare, instantiate, and initialize the reference type variable. Why I use this one? Because I knew why I use reference type variable slide here, because I need it for the next topic, which is wrapper classes. Wrapper classes are the corresponding classes to primitive types. They are immutable. It means that if you create an object, then you cannot change it. They all are final classes. You have to create another object and then assign to the reference type variable. You cannot do the changes in the object. The beauty of wrapper classes, they can hold a null value. Your primitive cannot do a null value. So for example, if you are storing a user location data using latitude, longitude, it would be a bad idea to store a missing point as 00, since that refers to an actual location off coast of Africa. So 0 latitude means equator, and 0 longitude means a GMT, and on equator GMT, this is a place in the off coast of Africa where the user could theoretically be. So in such type of a scenario, wrapper classes are really helpful. So if you can place the null value, which is quite effective. Another beauty of wrapper classes, they all are compatible of auto boxing, which started in Java 5. The compiler automatically converts a primitive to corresponding wrapper class. Like if you write 120 integral value in a wrapper class integer, so it automatically converts into integer object. And unboxing, the compiler automatically converts a wrapper class to primitive. So the character dot value of C, So if you call this method, the character object automatically converts into a character primitive. Okay, next. Null. As I said, the null references can be assigned to any reference variable. So all wrapper classes are eligible to accept null as a value. So remember that calling any method on null gives a null pointer exception. If the object uh, doesn't store any memory address of object in the heap, and if you call a method of a class, it gives a null pointer exception. Okay, let's make another method, public long wrapper, and return 1L. So the first corresponding wrapper class is Boolean, and we are going to create an object of Boolean class by directly assigning a primitive literal to an object, same like as we do with a string. This is called as auto boxing. What would if I have Boolean primitive type variable? I can assign a Boolean object to it. So method value of returns an object, and I'm assigning an object to primitive, which is called as unboxing. Before Java 5.0, we used to do like this. For getting the value from a primitive to a wrapper, use boolean dot value of. So there are two overloaded methods, one with primitive literal, another with string, and this string is not case sensitive. And we use a parse method from string to primitive value. But with the Java 5.0, we can directly assign a value to the wrapper class. The next one is byte, and we can directly assign an integer literal, and short we can assign same integer literal. Integer we can assign integer literal. Long we can assign a long integer literal. We cannot assign integer to it, remember that, as we could do in primitive. For float, we cannot assign double value, we can assign float value similar to primitive type. And double, we can assign a decimal value which is by default double. So any decimal value is by default double, any non-decimal is an integer. And we cannot assign float value to double as we could do in the primitive. With the character, I can directly assign a character, and Characters are based on Unicodes, so I can assign integer value between 0 to 65,535, same as primitive class. Can we assign character to a byte object? Yes. What about short? Yes. What about integer? We cannot. Okay, remember that. So this is our summary class. I will come back on this class. Value of method is in each wrapper class, and the input of each wrapper class is corresponding primitive type. Here we have a byte B. When we put 1 here, so we do not have B for byte, S for short, as we have F for float and L for long in the Java. So we have to cast integer to corresponding primitive type as an argument. For long is a long primitive type which can accept integer. Here you can put 1.0f or float. Both work. For the float primitive type, double 1.0 by default, any decimal is double. Here in the methods argument, literal value won't auto box into byte and short as we have seen in the assignment. So assignment is little different than method argument. We have seen that we have a parse and value of with a string with each wrapper class, and parse returns primitive type and value of string returns the wrapper class string. This is the old way of doing. The character class doesn't participate in above parse method and above value of this, which is the overloaded string versions. Okay. Java operators. A Java operator is a special symbol that can be applied to a set of variables, values, or literals. Operands, the value or variable the operator is being applied to. If I do 3 plus 2, then 3 and 2 are operands and plus is an operator. I have changed to the project directory and opened the JShell. 3 plus 2 is 5. 3 and 2 are operand and plus is operator. There are 3 types of operators: unary, binary, ternary. Unary take 1 operand, binary 2, ternary 3. If I initialize one variable cookies equals to 4 and another double rewards equals to 3 plus 2 multiplied by minus minus cookies, then minus minus cookies has higher precedence than multiplication and addition. The value of a 4 will change into 3, then multiplied by 2 becomes 6. 6 plus 3 becomes 9, and then this integer promotes to double. Operator precedence. It means determining which operator are evaluated in what order. For that we need order of precedence. As we have seen that post and pre have higher precedence than addition and multiplication. So in this table, top rows have higher precedence than the bottom one, and this is a decreasing order of precedence. If two operators have the same level of precedence, then the Java guarantees left to right evaluation. So it's top to bottom and left to right. To memorize this table, you need to remember post President of United States for post, pre, and unary, and for your basic math class, my dear Aunt Sally for multiplication, division, addition, and subtraction. Remember that parenthesis can change the order and has a higher precedence than post unary operator. For rest of that, you can remember senior L station. So for S and R is shift relational, E and L is equal, logical, STA, short circuit, ternary, and assignment. You need only the bold one to remember for your exam. Unary operators. So there are 6 unary operators. Logical complement operator, it inverts a boolean logical value. Plus indicates a number is positive, although numbers are assumed to be positive in Java unless accompanied by a negative unary operator. Negative indicates a literal number is negative or negates an expression. Plus plus means increment by 1, minus minus decrement by 1. Bracket type means cast a value to a specific type. You cannot apply a negation operator to a Boolean expression, nor can you apply a logical complement operator to a numeric expression. So let's see that. Let's define a Boolean is animal asleep equals to false, and if I use logical complement operator, it will invert the value from false to true. Let's see negation operator. If I have a variable zoo temperature and I assign 1.21 temperature, pretty cold, and if I do assign a minus, so the value will change to minus 1.21, and if I assign minus and then again minus, what would happen? So now the value is minus 1.12. Minus multiplied by minus gives plus, and this minus sign change the value back to minus 1.21. As I have said earlier, you cannot use logical operator with number, and you cannot use negation with Boolean, and you cannot use logical complement with number. If you assign a logical complement with a number, compiler will give you an error. Let's see increment and decrement. If the operator is placed before the operand, referred as pre-increment operator and pre-decrement operator. So what would happen? The operator is applied first and the value returned is new value of expression. So if I have int park attendance equals to 0 and I do plus plus park attendance, it will increment the value and then return the new value of expression. Just check the park attendance is 1. And if I do a post increment operator or post decrement operator, then the original value of expression is returned first and then operation applied. So right now the value is 1. It returned the 1, and after returning the value, it has updated park attendance, which means that subtracted 1 and value is now 0. Let's do one more example. If I say int line equals to 3 and I say int tiger equals to plus plus line multiplied by 5 divided by line minus minus. So what would happen? So in this one, line value is 3. Here is a pre-increment. 3 plus 1 becomes 4, and then multiply by 5 becomes 20. Line value updated to 4. 20 divided by 4 becomes 5. So line value is 4 and minus 1 becomes 3 after the operation. So first it will return and the tiger value is 5, and after, if we check the line, it has gone back again from 4 to 3. Okay, I will come back for the casting. Next, binary arithmetic operations. So there are 5: add, subtract, multiply, divide, and modulus. Modulus returns the remainder. Let's see that. Int price equals to 2 multiplied by 5 plus 3 multiplied by 4 minus 8. So multiplication has a higher precedence than plus and minus. 5 to the 10, 4 to the 12. 12 plus 10, 22. 22 minus 8 is 14. Okay. You can change the order of operation explicitly, manually, by wrapping parentheses around the section you want to evaluate first. So if I put a parenthesis here, I would like to evaluate this one first. And then I want whatsoever comes multiply by 4 and then 8. So now you can see is 48. 5 plus 3, 8. 8 multiplied by 4, 32. 32 minus 8, 24. 24 multiplied by 2 becomes 48. Now about the parentheses. You can change the order of operation explicitly by wrapping parentheses around the section you want to evaluate first. The parentheses must be balanced. All left parentheses must be closed by right parentheses before the end of expression. If I do long pigeon equals to 1 plus 3 multiplied by 5 divided by 3 in a block. So you can see that one parenthesis is missing. So if I say in a block int blue j equals to 9 plus 2 plus 3 divided by 2 multiplied by 4. So you can see that here also I closed the one but I haven't put anything, and I have opened the one but I haven't closed. They are not balanced. It gave an error. So if I do short robin equals to 3 plus 4 multiplied by 2 plus 4. So you cannot replace a parenthesis with square or curly bracket. I know it is allowed in the maths, the first curly and then square and then round, but you cannot do here in Java. So it gives an error. Now let's see a modulus operator. If I do 9 divided by 3, it gives 3. If I say 9 modulus 3, so 3 3s are 9 and remainder is 0. If I do 10 divided by 3, 3 3s are 9. So 10 is integer, 3 is integer, result is integer. So it comes 3, not 3 point something. If I do 10 modulus 3, so it's going to give me 1 because remainder is 1. Same thing, 11 divided by 3, 3 3s are 9. And if you do mod, it gives 2. 3 3s are 9, 10, 11 and 2 numbers left. If I say 12 divided by 3, it's a whole number. 3 4s are 12. If I do modulus, so remainder would be 0. So you can see that the result of the modulus operation is always is 0, 1, 2, and then 0 if it is a 3. So from 0 to 1 less. The modulus operation is not limited to the positive integer value. You can also apply it to negative. If I say 10 modulus 5, so it will give 0. And if I say 11, if minus 1, and 12, minus 2, 13, minus 3, 14, minus 4. So you can see that if the modulus is 5, the remainders will be between 0 and 4, 1 less. All right. Numeric type promotion. If we have two different data types, then Java automatically promote to larger data types. If one is int, another is long, and if you do some operation, it automatically promote to long. If integer and floating point values, then Java automatically promote the integer value to the floating point. So if one is floating point and another is integer, Java automatically promote to floating point. Smaller data type named byte, short, and char are first promoted to int before binary operation. So if you have a two short values and if you want to add them, so they promote into the int. And if you are again going to store them into the short, compiler will give an error. Remember that. Unary operators are excluded. For example, plus plus to a short value result in a short value. So it doesn't apply to the unary operators. So after promotion, the resulting value data type as its promoted operand. When the promotion occurred, then operands have the same data type. The resulting value will have the same data type as its promoted operand. If I have x equals to 1, long y equals to 33, and we do var z equals to x multiplied by y, z is a type of long. Let's do a little bit trick here. If I have a double x equals to 39.21 and float y equals to 2.1 and var z equals to x plus y. So what would be the type of z? You can see that by default decimal values are double, and this one is double, and you are storing double into float, it will give a compiler error. So it's a tricky question. Next, if you have a short x equals to 10 and short y equals to 3, and you want var z equals to x multiplied by y. So what is the primitive type of z? According to the rule number 3, byte, short, and char first promote into integer. So 3 times the 30th is an integer. So type of a z is integer. If you are going to store back x and y value into x, then it will give a compiler error. Alright, because after promotion you are storing them into the shorter one. But if you do a pre-increment or decrement to the short value, it won't affect. If I say x equals to plus plus y, x value is 10 and y is 3, so 3 plus 1 going to be 4, so it won't going to promote, okay, and it gives the x value 4. Okay, so unary operators do not promote. Let's do one more in a block. If I have a short w equals to 14, float x equals to 13, double y equals to 30, and var z equals to w multiplied by x divided by y. And if you do system dot out dot println z, so what it would be, short first multiplied by float becomes float, and then divided by double, so promote to the double and store double, so it is a double value. Assignment operator. Assignment operator assigns the value on the right to the variable on the left. For instance, if I have long wolf equals to 5, it assigns the value of a 5 into variable wolf, which is on left hand side of equal. The result of an assignment is an expression in and of itself equal to the value of assignment. So what it means, the result of an assignment, if I say wolf equals to 3, and if I would like to assign this one into another variable coyote, the result of assignment is an expression in and of itself equal to the value of assignment. So first 3 will assign to the wolf, and then it will return the 3, and coyote will have 3. Okay, wolf is 3 and coyote is 3. Okay, let's see if I have a boolean healthy equals to false, and if I say if healthy equals true, and I say system dot out dot println good, so what would happen? The healthy, which contains false, in the if statement the true will assign to healthy, and if any expression inside the if statement is true, then it executes if block. So if there is only one statement, you do not need to put curly brackets, so you can omit it. So it's all up to you. Okay, it says good, or you can write like this as well if you like. Alright, so both are true. Casting. It is a unary operation where one data type is explicitly interpreted as another data type. It is optional and unnecessary when converting to a larger or widening data type. If you are putting integral value to a long, so it is optional and unnecessary, but it is required when converting to smaller or narrowing data type. Like if you want to put a long into integer, it is required, or converting floating point to an integral value, or if you want to convert a floating point to integral value. Remember that if you do like this, floating point to an integral value, any value after decimal will be truncated. Without casting, the compiler will generate error when trying to put a larger data type inside a smaller one. Let's see that. I create an integer int fur, and I can write 5 here, or if I can write int here, so it is an extra. If I do int here equals to short 2, so the integral value is now short. In Java, there is no alphabet S for short or B for byte. We use a short keyword in front of integral value to convert the integral value to short. So short is going into here 16-bit into 32. So it's perfectly fine. Now string type equals to string bird. So I again have put extra type in front of the string literal, which is perfectly fine. Short tail equals to 4 plus 10. So 4 is integer, 10 is integer. 4 plus 10 is a binary operation, promotes to integer, result 14, and now integer value can automatically store into short without casting. And if I put short in front, it is an unnecessary step. So everything I can do without. Compiler won't gonna give me error. If this question comes in the exam with 4 plus 10, and by default 4 integer, 10 integer, binary operation, integer, literal can demote to short, but variable cannot. Remember that. And if I put long feathers equals to 10 long, so now the type is after the number, compiler will give an error. Let's do some more. Float egg equals to 2.0 divided by 9. So here what is going on? Integer and double promote to double. Double cannot go into float. I have shown you in the summary class, until and unless you explicitly cast the float. If I have int tadpole equals to int 5, which is redundant, multiply by 2 long, so what is gonna be happen? So 5 is integer, 2 is long, it promotes to the long. Long cannot go inside the int. Okay, only the demotion from integral value to a data type byte and short happen if the value is in between the range. If I do short 3 minus 2.0, 3 integer convert into double, and answer would be 1. Double cannot store into short. Let's try some more assignment. Fish equals to 1.0 cannot. Short bird equals to 1921222. We know that the range is until 32,000 and it is 192, which is bigger, so not possible. Int mammal equals to 9f, we cannot do. Long reptile equals to 192 1Z0-8198193810323, and this value is definitely greater than maximum value of integer. So until and unless we do not convert it into the long, it cannot store in the long variable. So how do we make it happen? All these problems we can solve through casting. So Control L is clear the screen in JShell. So here 1.0, if I put int 1.0, anything after decimal it drop, and before decimal it put in the variable. Okay, now short, so this is bigger than short, so I put short to cast it into the short and stored as 20678. And if I say int mammal, how can I do? I can write down int in front, so it will save 9. And this one, if I can put L at the end, or small l, preferably the capital L, so you can easily see that it can be stored. Overflow and underflow. It is not in the exam, but overflow is when a number is so large that it will not longer fit within a data type. So the system wraps around to the lowest negative value and counts up from there. So you know that the integer maximum value is 2147483647 is the maximum range of integer, and if you add 1, it goes all the way to the negative range. So 2147483647, this is the maximum range of integer. And if you do +1, so it will go all the way to the negative range. So integer dot min value is that. Okay, what about if you put 2? It goes to the second last. What's happening that it wraps around to the lowest negative and counts up from there. Underflow means leak happen from the bottom when the number is too low to fit in the data type. We know that the byte is from -128 to 127, so -200 is too low, so byte b1 equals to -200, so it won't let. Next is short mouse equals to 10, and short hamster equals to 3. And now I make a variable capybara equals to mouse multiply by hamster. So what would happen? So both short will convert into int in the binary operation, and now this is a variable, it's not a literal. So you have seen before, the literal can store into the short, but variable cannot. Remember that. And it will give an error. If it would be 10 and 3, if I write here instead, it could do it, but for this one it give an error. Remember that. And then to avoid this, I'm gonna convert the product into short and then store into this. Okay, what about if I have one more variable, name Gabriel, and this is a short. Now it's coming from the variable, and I say 1 plus. This all will promote to integer and it won't gonna compile. Okay, whenever there is a variable involved with the literal, so remember it won't go, but only all literals they can go in, okay, to the short. So I would like to complete my summary class. It will be very beneficial for you for the exam preparation. Let's see. So for the casting, if I write byte equals to 1 over here, So it means that the byte value is going into the byte. What about if I put the short here? So now short value, the short literal can store into the byte. How the short will demote to byte if it is in the range between -128 to 127. Okay. So this is byte short. And what about if I have long? If I have a long, I have to cast into either byte or short, which are byte short and int automatically convert into the byte. All right, remember that. What about if I have 1.2345 f a float? So one of them integer byte, one of them integer short, one of them integer short byte. What about if I have double? B equals to 1.245. Anything with the decimal is double, so I have to cast. Here I have to cast, and here I do not need to, the three of them. Okay, if I can put over here int is unnecessary. Okay, so 1 2 3 4 5 6 7 of them with the exception of boolean. So you could do the pretty much same as I have done for short. So and you can do the same for integer. So byte is a small, it can go into the integer, no issues. Same thing, short can go to, no issues. And integer can go to integer. What about if I have long? So for that the casting is necessary. You can put here int byte short, whatever you like. Okay, so if I can put here byte, that would be perfectly fine too. All right, if it is, even though if it is in the range, so do not put any value like 128. So you can put any, so byte too, so you can put any value. For clarification I would like to put int. And the same thing with the float and double. So all primitive types with the exception of a boolean can assign to each other, and some require casting and some do not require casting. Look at that, all seven. Okay, if they are literals. And what about the long? Long has is pretty much same like as byte. So So you can say long equals to 3.14f and long equals to 3.14. So you can put anything byte, short, int, or either long as well. Okay. One, two, three, four, five, six, seven. Okay, it's the same thing with the float. So you can put f equals to byte 1, the small data type it can go, and also short can go into int, long, float, and what about double? If you want to put the double, you have to put here float. Okay, so if you do not put the float, what's gonna happen, it won't store as a decimal value. If you can put the int over here too, then store only 3.0. Okay, remember that. Next is double. So byte, short, byte, short, int, long, float, double. And the last but not least is jar. So jar is c equals to byte 1, c equals to short 1, integer, and then if you do c equals to 1 long, so you can put int byte short. I'm going to just put the short here, and c equals to 3.14f. So it will truncate 0.14, and if I say c equals to 3.14 double value, and then I'm gonna put short, it behaves the same as a float. Alright, so this method is complete, and you need to know that what casting is necessary and what is not. So, and there's no byte and short, as we have a long and a float. So we have, for the byte value, short value, we need to put like this. Okay, let's see some primitive class. So let's do a little bit byte and short from here and see that can we put it over here. Yes, we could. And let's put some short and byte over here and see that can we put it over here. Yes, we can do in a wrapper class as well, but remember that for long integer, how it would be, Yes, we can do it. What if I can change into byte? Yes, this one short. Yes, so it's going the anything the decimal it's going to truncate. So anything with a short, let's see. So yes, it works. What about integer? Can we do it with integer? Let's see. No, we cannot do with integer. Only with a byte and short. Remember that. What about the other values? So you have to explicitly mention int. What about if you can put the byte here? No, you have to explicitly mention only int. What about the characters? Not allowed. So you can have to put int for that. Okay, so it's becoming interesting. What about long? If I put here, it allows. What about if I put long equals to 1, as I know that it doesn't allow? What if I put long in front? Yes. So integer, long, float, double, and long equals to long character. So yes, with the wrapper class you need a specific class. What about short? What about float? Can we do like this? I think no. Yes, we cannot do like that. And what about the rest? So yes, we can do with the double. For character we have to mention like this. What about the long? We need to mention like that. And what about integer? We have to mention float. So if you make a byte, you have to make a float as well and short in front of it. So same thing with the double and the character. Okay, and I'm going to complete this class. or character short. What about byte? Yes. What about int? Yes. What about jar? Yes. C equals to int 1. So character also works pretty much same like as a byte and a short. Okay. So this is the summary class, very helpful for your exam preparation. Next, compound assignment operator. So there are 4 compound assignment operator. Plus equals to, minus equals to, multiply equals to, divide equals to. So what it does actually, it operates the value on the right hand side to available variable on the left and assign the value to the variable on the left. So how it is, to clarify, I would like to make a class compound operator, and make a method public static void main. If I have a camel variable and giraffe variable, and both are initialized, and if I do camel equals to camel multiply by giraffe, so what it happens actually, the product of 2 will assign to a camel. I could do this one by multiply equals to giraffe, so it serves the same purpose. Camel, and here also camel. So if I run this class, the 2 multiplied by 3 is a 6, and here the value is already 6. 6 multiplied by 3 is 18. So this one is exactly same. It means that multiply left and right and assign to the left. If this is an add, then add 2 variables and assign to the left. Minus 2 variable and assign to the left. Divide 2 variable and assign to the left. What it says, the left side of the compound operator can be applied only to the variable that is already defined and cannot be used to declare a new variable. So what it means? It means that if I do not assign a variable, so I cannot use either way. So for compound is pretty much same as a normal operation. You have to assign a variable before you use. Okay. Second, it explicitly casts a value. Let's see that. I have long goat equals to 10, and then int sheep equals to 5, and if I want to do sheep equals to sheep multiplied by goat, so it will not compile. What it says that required type int provided L long. So sheep is int, goat is long, so you cannot assign a long into a sheep. But if you do sheep multiply equals to goat, so this is the benefit of compound statement. The compound operator will first cast sheep to long and apply the multiplication of two long value and then cast the result to int. Here it's not doing a casting to int, okay, and this one is automatically doing casting for you to accommodate. All right, so that's a advantage. All right, comparing values. There are two equality operators, equal, equals, and not equals. So for primitive, if both values are same, it returns true. And for primitive, if both values are not same, not equal, returns true. For the object, this operator, first one, equal, equal, returns true if the two values reference the same object, and not equal return true if two values do not reference the same object. So there are three scenarios for equality operators. Number one, comparing two numeric or character primitive types. So if I write 5 equal 5.0, what would happen? One is integer, one is double. Integer 32, double 64. So it will promote left hand side to double and then compare both values. If they are same, it will return true. Okay, next, comparing two boolean values. Boolean value like 1 is true equals to true, so it returns true. If you say true equals to false, so it returns false. Okay, so here instead of true and false, it could be any boolean expression as well. Comparing two objects including null and string values. So if we have string name1 equals to Sam and string name2 equals to Sam, and if I say name1 equals to name2, so it returns true. The reason why? Because name1 and name2 point to same literal. String is a little bit different. It stores its values in the string pools, and if you say new string, then it will create an object and also put the value in the string pool. Let's see if I have a file Monday equals to new file schedule.txt, and if I make file Tuesday schedule.txt, and now I make a reference Wednesday and assign the value of Tuesday in the Wednesday. So Wednesday and Tuesday point the same object, and Monday and Tuesday point a different object. So with the new, it creates a different, however the values are same but they are different object. So if I say Monday equals to Tuesday, it will give false. And if I say Tuesday equals to Wednesday, it's gonna give me true. Okay, so two references are equal if and only if they point to the same object or both point to the null. If some object point to the null, another object also point to the null, so it will give true. Okay, so the comparison for equality are limited to the three cases which I have shown you. You cannot mix and match. For example, if you say boolean monkey equals to true, right? Now you cannot do like this, equals to 3. So what would happen? Equal have a higher precedence than the equal. Then this is a boolean and it is a number, so there is a compiler error. All right, so boolean and integer. Same thing, if I say boolean a equals to false, not equals to grape, what it happened? This one is a string and one is boolean, so not equals to has a higher precedence than equals, so both expressions are not boolean, so it will give a compiler error. Should be both booleans, or should be both numeric or both character, both same type of object or both null. If I say boolean gorilla equals to 10.2 equals to cuckoo, so one is string, one is double decimal value, compiler error. So as you know, we can assign the result of one variable into another variable if both are same type. So first we assign true to the beer, it changed the beer value from false to true, and then it returns the true, and we are assigning that true value to the polar. So now polar and the beer both contains true. Okay, so polar has come true, and if you check the beer as well, it's also true. Relational operators. We now move on to relational operator which compare two expressions and return a Boolean value. So this is a less than, this is less than equal to, this is greater than, and this is greater than equal to. Always go left to right, and if you are on the left and the mouse is closed, is a less than, like a letter L, less than equal to. And if you are here and the mouth is towards you, is a greater. So remember that. And is instance of B. I will explain through the example. So int given num feet equals to 2, wolf num feet equals to 4, ostrich num feet equals to 2. Okay, now given feet, if I say which is values 2 and I say less than wolf num feet, so it's a true expression. And if I say less than equal to, so it compares for less than and as well as equal to. So which is true. Okay, check for both. If I say given num feet is more than equals to ostrich feet, so it is true. And if I say given num feet 2, ostrich feet 2, so 2 is not greater than 2, 2 is equal to 2, so it gets false. Okay, let's check the instance of. So for instance of, I would like to mention that integer is a subclass of number and number is a subclass of object. Object is parent of all the classes in Java. So let's make an object integer zoo time equals to integer dot value of 9. And now I'm creating a reference of number class, which is a parent of integer, and trying to store integer reference into number. Can I do it? Yes, I can do it. An object is a superclass of all classes. What about, can I store the grandchild class zoo time into object? Yes, I could do it, which is called as polymorphism. Let's make a method. Public void open zoo number time, and if I say if time instance of integer, then system dot out dot println integer time plus o clock, else system dot out dot println time. So the time is an instance of integer. Print time with o clock, if not just the time. So method created. So what this method does, if I put open zoo time instance of integer 5, so it puts 5 o'clock. Now if I put 5.0 float, and it is not an instance of integer, however it is a number, so all wrapper classes extends from number, so it will say 5.0. What about double? Yes, so just say 5. So you can see that we are casting time. We are sending here integer. This number is holding integer value, as you can see there, and then we are checking is that integer is an instance of number or not. If it is, then cast it. This is cast, and then add o clock with it. So it is considered a good coding practice to use the instance of operator prior to casting from one object to a narrower type. Okay, so this is a number and we are casting to narrower type integer, so it's a good coding practice. What would, if I put the class here which is not the subclass, so compiler will give a compiler error. Remember that here you can always put same class like a number, subclass, or any interface which this class implements. Like integer can implement serializable, comparable, table, constant description. So anything other you cannot. If I put the string, so what would happen? It will give a compiler error. That's what we are saying over here. It returns true if the reference that points to is an instance of a class, subclass, or class that implements a particular interface as named in B. So the B could be same class as A, child class, or a class that implements the interface which implements by A. So here you can put B as a same type of a class, subclass type, or a type which implements an interface that implemented by a superclass. Okay, null and instance of operator. What would if I say null instance of object? Here you can put the class name or also the reference name. Both work equally fine. So it always gives false. Okay, null cannot be instance of anything. What would if you do object is an instance of null? So it always give a compiler error. Okay. Logical operators. They can applied to numeric and Boolean data types. When they are applied to Boolean, they are referred as logical operator. Alternatively, when they are applied to numeric data type, they are referred as bitwise operator. For your exam, you only need to know. So there are three: operator, and, or, exclusive or. To understand this, logical and in between two expressions, if both expressions return true, then it returns true. If either one returns false or both are false, it returns false. So remember that and is only true if both operands are true. For inclusive or is only false if both operands are false. Both operands are false, it is false. Either one is true, it gives true. Exclusive or is only true if the operands are different. Both true, false, both false, false. Otherwise, it gives true. Okay, let's see that. Boolean eyes closed, equals to true. Boolean breathing slowly equals to true. Okay. And if I do Boolean resting, which is eyes closed or breathing slowly, so either one is true, it gives true. And if I say Boolean asleep equals to eyes closed and breathing slowly, which gives true. Because both are true, it gives true. Boolean awake equals to eyes closed, exclusive or breathing slowly. So both are true, it will give false. Okay. Next, short circuit operator. So there are two short circuit operators. So they are identical to the logical operator and OR. So we put double and double OR for the short circuit. What is the difference? That right side of the expression may never be evaluated if the final result can be determined by the left side of expression. It means that if the short circuit AND is true, if both values are true, if the left side which is evaluated first is false, then it never goes to the right hand side. Okay, so examiner will check your concept of this. There is a question in the exam where the right side of expression increment a variable, so keep this thing in mind. Short circuit OR is true if at least one variable is true. If the left side is true, then right side will not be evaluated. Okay, let's see that. int hour equals to 10, and then I define the zoo open a boolean variable equals to true, short circuit OR hour is less than 10. So our value is 10, 10 is less than 4 is false. So this one never evaluates, it always gives true because of short circuit operator. Short circuit operators avoiding a null pointer exception. A more common example of where the short circuit operator are used is checking for null objects before performing an operation. Let's create a class animal int age is the field member, and public void set age int age this dot age equals to age public int get age return age. So we have created a class. Now I'm going to create a reference, by default assigned to null, and if I say if duck is not equals to null and duck dot get age is less than 5, then system dot out dot println say hi. Okay, so if the duck is not equal to null and age is less than 5, then then say hi. So you can see that duck is a reference and we have not created an object of a animal class. This is just we create a reference. So whenever we call a method on a reference without creating it, it will give a null pointer exception. Okay, what would if you do the same thing with a short circuit? So short circuit will only evaluate the first expression, and as the duck is null, it won't gonna evaluate the expression on right hand side. Okay, so the short circuit prevents a null pointer exception from ever being thrown, since the evaluation of duck.getAge is never reached. Okay, checking for unperformed side effect. Be careful of the short circuit behavior on exam, as questions are known to alter a variable on the right hand side of expression. They may never be reached. This type of a question is in the exam. So if I do int rabbit equals to 6, boolean bunny equals to rabbit is more than equals to 6, or plus plus rabbit is less than equals to 7, so here the value of rabbit is 6. Rabbit is more than or equal to 6 for short circuit, or if any expression on the left side is true, it won't gonna evaluate the expression on right hand side. So this is true, it's gonna evaluate true. And if you check the value of rabbit, it is remain 6. What about if I do this one? So it will first increase the value to 7, and this is also true. So it returns true, but what about if you check the value of rabbit, it has increased. So for the short circuit, this expression never evaluated, but for the logical OR, it has evaluated. Okay, remember that. Ternary operator. The final operator you should be familiar with for the exam is the conditional operator, also known as ternary operator. Ternary operator has 3 operands: Boolean expression, followed by expression number 1, followed by expression number 2. Boolean expression, expression number 1 separated by question mark, 1 and 2 by semicolon. It is also a short form of if-else statement. Let's see that. In the J shell, if I declare any variable, so it is pretty much declaring a field in a class. Be careful. If I write down any variable without any initialization, so it automatically initializes. This behavior is contrary to the local variable. Local variable inside the methods, inside the blocks, inside the constructors are not initialized by themselves. So if owl is less than 2, food equals to 3, else food equals to 4. And if I write food here, food 4. Okay, so pretty much 1, 2, 3, 4, 5, 6, 7, 8. 8 lines to check the value of a food. I could do everything in 3 lines, like I can initialize a variable for food. I could do out less than 2 question mark 3 semicolon 4. So, and in the J shell you do not need to terminate the line if your code doesn't go beyond now one line. So if you put the semicolon or not, it doesn't matter. So the owl is less than 2, so this expression returns 3, pretty much same like as if statement, which assigns the value to the variable. Otherwise it returns 4, and here assigns the value 4. So this statement returns the value which you can further assign to a variable. You cannot write int food outside here and expect that if statement going to return anything. Okay, so you can see that the food value is 4. All right, or if you can in your main method also check what is the value in the food, so it is 4. All right, remember that second and third expression, which is expression number 1 and expression number 2. All right, so this is first, second, and third, and here the second and third expressions means these expressions can have different data types. I can write int stripes equals to 7, and then if I say stripes are more than 5, then print 21, otherwise zebra. Okay, so I is 7, which is more than 5, so it will print 21. Okay, what about if I initialize a variable animal? By the return of ternary expression. Says that if the stripes are less than 9, return 3, otherwise horse. This expression doesn't compile because int can only contain integral value, not string. Okay, next, checking for unperformed side effect. It is pretty much same as short circuit operator. Let's declare two variables, sheep value 1 and zzz value 1, and int sleep zzz less than 10, then sheep plus plus z plus plus. So if zzz is less than 10, then it will return the value of a sheep and then increment the value by 1. So sleep is 1. If we check what is in sheep and zzz, sheep has incremented to 2 and the expression number 2 has not evaluated. Let's assign again the same variables and change this expression so that we can evaluate the second one. Z value is 1, which is not greater than or equal to 10. It will not evaluate the first one, it will go to the second one. The variable value is 1, it returns a 1, and after returning, it is a post increment increase the value of a z to 2 and the value of a sheep will remain same. So if I see the sheep and z, so it gives 1 and 2. So the first one, it has incremented the first expression, and second one has incremented the second one. Okay, so be very for these type of tricks in the exam in which the variable is modified in one of the right hand side expression. All right, so now save this file into operator minus all dot jsh, and now the file is stored in the project, the same name in which we have saved, and all these commands which we have typed throughout the J shell are over here. Okay, I'm going to upload this project on the GitHub and you can run all these commands. Make sure that whenever you use your command prompt, go to the project folder and then start the J shell and open the file operator minus all dot jsh. So it will load all the commands and you can see list minus all these commands which we have typed throughout are over here. Okay, and the E represent error. So it is pretty nifty. I hope you like my video. Please provide your feedback and thanks for watching. Wish you best of luck for the exam. Thank you.